My keyboard is broken, damn it. This space feels completely different than the other space. And the A doesn't work anymore, so every now and then you have to open it and clean it. And suddenly we realize that mu and beta are the same thing. What? No, they are not. The equation for No, totally not. Unless maybe gamma 0. Yeah. Hello, Mohammed. Yeah, it's not really code, is it? But okay, I'll talk if I have yours. I have yours. It's very complex though. So this is a sigmoid function, 1 over 1 plus e to the power minus x1 in this case. And then I scaled it a bit. So I'm secretly using x minus b over w. I mean, normally the sigmoid function is a half when the input is 0. So in order to make it a half at minus b divided by w, we have to subtract that from x. And it's scaled with s. So I think if s is larger, then it gets wider. Which means already you have to divide by s or multiply with w. In other words, this line here, this shows two sigmoid functions. X minus mu. Mu and beta are the same thing here at the moment because, well, I set a gamma to 0. But that's, stuff up here, which we skip for now. So mu is the mean. In this case, it's actually the mean of the underlying logistic distribution function that I use to blur red and green half planes. So then you get the distribution of pure red here and pure green here, and in the middle is a bit fuzzy. And the underlying logistic distribution looks a bit like a normal distribution, like this. Has a width or a standard deviation. Proportional with the scaling factor. And that works by just simply x, so the horizontal thing, divide by s before you plug it into the normal sigmoid function. So I have mu and s given for both. So obviously for the one that is steeper here, means that s is smaller. I say that, but is that true? So if you divide by a smaller s, then the parameter of sigma becomes larger. So it's like we go faster. So even with a small movement of x, it changes faster. Yeah. So the steeper this is, the smaller s is. And I was changing this because although I don't think it gets any simpler by putting stuff at 0 or 1. Might as well do the whole shebang at once. The most I can't think of the word. The most what? General case, yeah. So I was changing this from 0 to that. So the T here stands for target. Maybe I should write that, or I introduce it. Yeah, I already have that. The targets. Maybe I should use the A of actual. Target is already a bit used, right? Target is used for the I can't think of the word again, or remember rather, but the red or green values are targets. It's a bit overloaded. It's a target in the sense that you want to change this W1 and B until you reach that. But it might still be confusing. Do I have a subscript A? Oh, I do. Well, okay, let's use A then. I don't know. Yeah. Let me read the chat. Can you please recommend some good books for deep learning? No, I don't read books. I just started a month ago on this. So I'm not an expert yet, I would say. The level of my videos. Well, I started a month ago. I hardly knew anything about machine learning, but I know a lot about mathematics and coding. So I don't know. Level is always hard. It's hard because I don't know why. Yeah, it's hard because I'm smart and I'm working on it many hours a day. So if you just hop in and try to follow it, then you miss the previous 100 hours of hard work on it. So I don't think anyone can follow exactly what I'm doing. Because yeah, you just drop in the middle. But I'll keep talking ish about what is this. So that's the other one, which is then obviously this one. Well, I'm going to code in a bit. I just like to keep my README updated. So two sigmoid functions. Okay, my idea is to determine a likeliness that the training data would happen given the predicted distribution. Consider a single point at x is x. To chance that point, why am I cutting off suddenly here instead of there? Well, I don't know. Consider a single point x is x. The chance that this point is green given the current prediction is sigma x w1 plus b. You see here, if I say this and you read this, then you're like, yeah, what? Why? But if you read all of the above in this README, then that's kind of obvious by now. You know, it's like really simplistic. Yeah, okay, everyone knows that by now. The sigmoid is just giving the chance that a point at a given point is green. So take that for a given at the moment. Actually, let's show it 309, are we? So the conclusion was drawn here, I think. So the probability density of green at the coordinates x0, x1 equals sigma of, and then you get the equation that involves a line and a scaling factor. And that has been derived from this integral and stuff. See the Heaviside step function, the logistic distribution, which is given up here. This. It's not trivial in the sense that you can understand it at the moment that you see it. But you can follow it, and then you know it, and then it starts to become trivial because you know that it's just that's just how it is. Sorry, I can't give tips, really. I just started coding and I never stopped. And with a lot of decades and a lot of hard work, then yeah, who wouldn't become an expert? So there's no trick. You have to go through a lot of pain for a very long time. Nothing comes easy. So my only tip I have is always anyone ask anything like that is start coding and work hard. and then for a long time. And it will get very slowly better, little by little. So back to the text. Consider single point at x1. Yeah, x0 dropped out here because I would just assume the line is horizontal. The chance that the point is green with the current prediction is sigma wx. That you will recognize this as an output of a neuron, by the way. Which you can also literally see here, right? I mean, it's just, if x is small, then it is red. If x is large, it's green. If x is around here, then the chance is about 50%. Yeah, the more we go to the right, the larger the chance that it is green. So like literally the sigmoid here. Hence, if it is green, we multiply the total likeliness with that value. So if at this x-coordinate we see green, then the likeliness that that was green, given the x-coordinate, is the value of the sigmoid at that point, say 0.7. And while it is red, then the chance was 0.3 for that x, because this is the distribution. I just want to work on this, not something else. Distracting. I don't know. I show. Yeah, I mean, likeliness was defined as p to the power n green. If you take the log of that, you get n green I times the log of the p green I. And the multiplication changes into a plus because you took the log. And power again, so you get n I red times the log of that. So this multiplication sign changes into a sigma, and multiplications change into plus, and powers change into multiplications. Know your math. Logarithmic. If you take the log, and then we fill it in, and green is m times sigma, but I changed my coordinates into this coordinate parameter. Log sigma, the other sigma without m, and then we get here, sorry, the other parameter. And this is m minus the same sigma of the same thing times 1 minus the sigma of the same thing. I just put m outside of the front of the sigma. So this is divided by m divided by m. The likeliness when changing W1 and or B away from the best fit should give a smaller value, but will be non-zero too unless W1 and or B are brought to a limit. That is, the log of the likeliness will be very negative but still fit in an int, so it doesn't go to 0. Therefore, we first determine the optimal likeliness for W1. There we go again. Let's function how many I values we use. Here it becomes a bit fuzzy and flaggy. Fortunately, this is the end of the current end of the README. Yeah, this just becomes now I can just replace this with XA. Nah, maybe not. No, definitely not. XI. Okay, I'm just going to add this again, and I guess now everywhere. Well, I bet that for this formula, the value of BA doesn't matter at all. Because that would just be a shift in I, the value of I. Maybe sum from, well, we sum over everything. Yeah, I don't know what it did here. It doesn't look good. Don't think this should have been here. Right here I was only interested to show that it is not going to infinity, but actually I also don't think these two lines belong to this. I already changed it. Let me work this out. Just fill this in, I think. Excuse me, more. You go here. This should be that. And this too. What I do here is I divide, so we have the m in front of it. Now I divide by delta x, which is a constant in terms of I, before the sigma, and I multiply it inside, so that doesn't do anything. I multiply it and I divide it. Plus I split the sum in two. So we have here a single sum, and now a single sum is something with two terms, 1 and 2. And we split it up in two sums with those two terms. Oh wait, the log of likeliness was this, not likeliness opt. So really it comes from here then. So same thing, we do the sigma with just this term here. Times sigma and then times delta x and divided by delta x there. And then again here, m divided by, so this m divided by delta x times delta x. And then the sum of this term, which is 1 minus sigma, and then I have to change that again. This sigma times, yeah, now it's correct. And now we can, for delta x going to 0, we can replace this sum, including the delta x, with an integral. So this becomes now the integral from minus infinity to plus infinity of And now we do dx, so this changes into x, but it's x times w a plus b now, times the log of sigma x times w1 plus b dx. And then the exact same thing here. Well, that x is this x again, so that's the same as that. Times the log of 1 minus blah blah blah. Okay. And even mathematically I can't calculate it, unfortunately. This is something else. Could you just delete it? Now, even if you fill in the likeliness opt, we get, I think I'm going to recalculate it. So we get m divided by delta x plus the integral of minus infinity to infinity. But because now we have opt, we can replace w1 with wa and b with ba. And since those are constants, and we run from minus infinity to infinity, I think I have to do a replacement, right? Let's do that first. No, let's first okay. Let's just call it optimal likeliness and then ignore even that we take the log of it. Hello, Ava. I want to have that minus as well. Maybe I should not have done that. Let's move it one down. Yep, where optimal means that we replace this with the actual values. Now do a substitution. Let's say U is I think just WXWA. No, it's just the whole thing, right? Yeah, WA is W1, right? You have an expression of that. It is always positive. It better be. Yeah, W1 is just 1 over S. So, and S is always positive. Which it is, because it is the reciprocal of S, which is always positive. So in that case we get so dx is du divided by WA. And WA is again constant. So I'm just going to say du here and then divide the whole thing by WA as well. So I guess we'll just do this. Sigma u log 1 minus sigma u du. And yes, of course, I forgot to immediately divide by that. WA. Yeah, so the U is minus dV, and the limits change sign because, well, also, if U is plus infinity, then V is minus infinity. And then, of course, you replace U with minus V. Which is equal to, now I swap the limits again, which removes the minus sign. Yeah, it's just the same thing as this one. Do I have to spell that out? I don't think so. Let me just copy it. Why? Oh. I mean, the sigma of minus V is 1 minus the sigma of V. So then you get 1 minus... Wait a minute, then we have 2 minus signs. Do I have something wrong here? No, it's not. So it's correct. Great. And Mathematica can calculate this. I think I have it still like somewhere in... let me see, the integral. What the hell? Plot, integral. That's from 0 to infinity. Jeez, what the fuck? So I'm not going to copy this. So I'm not going to buy it, I mean. It sucks in every possible way, it seems to me. Paste? Yeah, you can just can't copy paste. Seriously. And it jumps up again. Maybe I had another one. Pretty sure I calculated it somewhere. Yeah, here. Integrate sigmoid x times the log of sigmoid x. That's what we have. Between minus infinity and plus infinity. That's minus pi squared over 6. So that becomes, I just need a line like that. Three times pi squared. Where's my pi? I had a pi. I used to have a pi. Greek pi? Is that possible? Yeah, now we got this. Greek small pi. Well, suddenly I can't find it. Seriously. How stupid can you be? UTF-8. Even with quotes, it can, oh, is there an existing map in Latin 1? Okay, I could not find it. Let me just remove quotes then. Now we can find it. Same side. And now we need a square, of course, which I cannot find. I might as well go here. Superscript 2. Well, and we divide by delta x WA. Well, there's an M here also. I don't know. Where do I want to have it? There? None of them. Okay, I'll leave it like this. 3 pi squared m divided by delta x WA. Now dividing by WA is the same as multiplying by S. The target is. Why is this not negative? I did something wrong. Yeah, what did I do wrong? Because it should be negative. It's the log of the likeliness. So the likeliness is very small, close to 0. So yeah, it's like minus a few thousands. Painful. Oh, I get it. No. Minus pi squared over 6. I forgot that minus. We can, in fact, empirically determine the correctness of this value. So that's what I'm going to do now. I think write a program that does numerically calculates this for some m and delta x and WA. How shall we call it? How about I call it likeliness opt.cxx. Int IOStream main. Yeah, it's not physics. Nothing to do with physics. I did study physics, but it's just mathematics. This. I'm gonna use my existing sigmoid from this because I'm lazy. And I probably also have an M. I don't. Ooh, impossible. Why would I not have an M here? Shocking. N equals 1000. Sorry, but it's like I'm looking at the wrong file. Totally looking. Am I looking at the wrong? It should have been logistic. Like logistic. I think it should have been logistic. Dual network is not it. Likeliness. Already have likeliness. It should have been likeliness. Da-da. Yeah, see, that's better. This one is pretty short. I think I'm gonna use this one. My AI is going to draw a line between red and green points. Yeah, NeoVim, yeah. I literally forgot. Standard deviation is S times pi over square root of 3. Oh. Right, so it's hard to see, but here's my sigmoid function, sigmoid, the dots. So it goes like this. And of course these points, pluses are way denser. So we can really accurately follow that. I want to run from, yeah, it's kind of unclear, I guess. Maybe I should have a separate variable for the number of, the total number of sigmas. What is full width? Don't want to use a W. Could just use width. But width times sigmas? Nah. Yes. So the whole thing is S sigma wide, okay? That's double. I mean, I'm going to fill in an integer, but well, it could be a double, isn't it? That's, in the end, we have a precise number of n and m must be integers, of course. So. But okay, by the looks of it, if this is 2s, then I have like, well, my 1s is, if you go the standard deviation to one side, you're at 85%. So this must be 0.85. So the standard deviation, if this is my curve here, then it is actually there-ish. So it looks like two of those. Yep. So we have how many? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, say 28. Divided by 2 is 14. So let's make S14. Integrate over plus or minus 7 standard deviations. I'm from the Netherlands. Definitely need to know dx. I need to know my S, I think, first. So do cons expression double S. And I could pick 1, but you know, you want to see the influence. So let's say 2 for now. Which means that the standard deviation equals S times pi divided by the square root of 3. Which means that the total width is S times the SD. That's what we promised there. And now we can calculate dx finally. Dx is the total width divided by I think n minus 1 or something. Yeah, I did eat one little thing. So I'm not hungry yet. I probably should go eat soon-ish. What other constants do we need? Mu itself. Yeah, I really have no idea why I would not put mu in the middle. Doesn't really do anything. Really doesn't do anything. But okay, cons expression double, long double. I think I'm happy with double at the moment. Let's say we're going to sit, we just integrate from 0, because that should not make a difference. If you have a sum u. And then I'm going to put mu at about, well, the total width times about a half, but not quite. So 0.6. Nah. Yeah. Nah. 0.4. Okay, that has to be 42. Blah blah. It even looks like it is, you know, like this mu is here and this is like 0.42 from the beginning, right? And then 0.6, yeah, absolutely. Let's check this again. N, that's those number of points. M is the height. S is the total width in sigmas. In standard deviations, excusez-moi. Standard deviation is pi over the square root of 3 times s. I picked s as 2, so that should work. Dx, the total width divided by n minus 1. And mu is just somewhere in the middle of the total width. That also means now that the beginning here is x is 0, right? I don't, this is correct, right? Pretty sure this is correct. Yeah, then I can delete this, I think. Or redo it later. What to do? What did I want to calculate? This value here. So WA is 1 over S. We have dx, and we have m, and we have pi, of course. I don't need that actually, I just want to calculate this. That's nonsense, I already know that. Yeah, probably should not look at it and just code it the way I intended it to be from the beginning. It is, however, the log likeliness, but then for the optimal values. So let me just call this log likeliness opt. We're going to run I from 0 to n. This gives me n iterations, so that's 1 for each point. To be good enough, certainly if n is very large. I might need that one. I might need everything, why not? So we define x as I times delta x, which means that x starts at 0. and it ends at n minus 1 times dx, which is total width. Um, let's change that back actually. B is mu, and mu is this, right? So equals gamma 0. Now the fraction that is green at x equals well, that's really just x times WA plus BA. It's the actual sigma. And then times m, of course. Which, because of this, equals P green I here. Probability to be red is just 1 minus probability to be green, because you don't have blue. just kidding. And that is also trivial. I mean, this one. The number of red ones is m minus the number of green ones, which makes the total exactly m, but we do have a bias here. Not really, because I'm just working with a double. So we get a fractional point, but not a problem. Yep. Okay, so then the likeliness is that. So the log likeliness is standard log of that plus log of that. Okay. Yeah, I have a formula for log likeliness as well. Log likeliness I mean. I don't. You gotta be kidding me. Nope, we just did that on the fly. Okay, then we do that here as well. So the log likeliness is that times that plus that times that. Well, it looks good. Definitely have a formula for this. Teal, hello. Oops, I want to have the not even sure what I want to have. The log likeliness. Yeah. I guess that one. Yup, so we just sum it, but that means that this is the optimal one, because that's what I call my variable, which means that this must be the optimal one. Which means I should have called this optimal. Optimus. And then we have printing the value. So this is the log opt. And I'm dividing it here by n times m. But really what I should do is divide it by m. Multiplied with delta x. Maybe even multiplied with delta x wa. Now, delta x is in fact a reciprocal of n, so yeah, dividing by m and n is logical. But let's just use this formula, and get rid of that. So we have this. I'm just gonna copy it. Just copy. Y. What am I doing? Space here. Yeah, so let's just divide by, or might as well multiply by, but well, no. Let's divide by m divided by delta x. Yeah, like that. And that should give me minus 3 pi squared. Now, wouldn't that be nice? M divided by dx times WA. Yep, my A is broken. It's not a number. Oh, really? You're going to do that to me? Well, I guess it becomes not a number somewhere in the loop. Oh, really? I already had a sigmoid there. Turned to long doubles. My god, I was already using long double everywhere. Didn't even know that. Realize it. Well, in that case, nothing won't have changed, right? Nope. Why the hell does it turn into not a number? 9,006. It's probably getting too close to 1. So 1 minus 1 is 0. That's pretty damn fucking close then, because it's a long double. Okay. Yeah, can't take the logarithm of 0. Let's make s considerably less, like 10. Nope. That doesn't look like pi squared times anything. It's almost 0. Is it the same value? More or less. I don't think it should change this function of m. That has a significant influence. I don't like that at all. And it's still small. Shit. Now this should not have any influence whatsoever, right? So I put that up on half then. Oh my god, that's a horrible influence. Why? How? Huh? What? I'm kind of surprised that this is nothing like I calculated. I mean, it's not a little bit off. It's like a huge amount of. It should be minus 3 pi squared. And it's like 0.0000 something. What? How? I guess I start with calculating the integral from 0 to infinity of this. See if I can get to 1/12 pi squared minus 1/12 pi squared. But let's first eat. Yeah, I'll be back later. Give me, I don't know, half an hour, I think, maybe. It depends on if I want to watch a movie. Let me see if there is a movie. Movies. To click on this. No, there's nothing. What is this? I think this is interesting. I'm going to watch this movie.